Hi, and welcome to another Hopper video. This one's a project summary. Um, over the last week, I've been making a couple of videos about different components of this project, and I'll make a playlist now that summarizes them, and this is the introductory video. So over the last couple of years, I've had this ongoing driveway lights project, which is an overkill solution and it started off with this Wemos D1 Mini device. And it actually is what made me decide to do Hopper in the first place. So I'm going to quickly give you a summary of what all the devices do, and then I'll show you, and then on the playlist you'll see how to use each of the different components. This little box is, you can see it sits underneath a television set in the living room to show you that the garage door is open or is not open, and you can also hit the button on top and update the screen with a query of what's happening on the other device. So this box is called the house box, sitting inside the house, and the second box is sitting inside the garage. Let me show you what that one looks like. Well, the second box isn't really a box yet. It's a circuit board sitting on a shelf next to the garage door. You can see that's the roller track of the garage door in the garage. I'll bring it inside so we can have a closer look at it. But it's not sitting in a box yet, but it will be soon. Okay, so here's a closer look at the first box. It's this nice little 3D printed case, and pop the back off, and then we can look inside. It's got a eInk display on it, and if you press this button, it'll send a radio signal to the other device to get some information and tell you, what the other device is seeing, like what the other device thinks the time is, that sort of thing. And inside, it's got a microcontroller. That's one of the Challenger boards from iLab, RP2040 board. It's got a little radio in there, this HC12 radio. It's got the button there, and then it's got two super bright blue LEDs, and they just shine straight through the 3D printed case, because I used a sort of a transparent color. It's not really transparent, but it's transparent enough. So and then the USB gets its power from the USB cable. And it's been designed so that all these things have to be slotted in, and then there's no glue. It all just sticks together. It all just sits where it's put. And it's got a force fit. This blue back is force fit, and it's got a little notch on the one side so I can undo it. So you just click it onto the back like that, and there you go. So that's the house box. Summary: microcontroller, HC12 radio, two LEDs, and an eInk display. Let's show you what's in the garage box. Well, it's not really in a box yet, but this is what's in the garage. So let's pop these out and have a look at what it's got. So it's got a power supply this is like a buck converter that's a drop-in replacement for a 7805, so it'll take the power for the driveway LEDs is like 24 volts or something. So it takes that down to 5 volts, so 5 volt supply, microcontroller. And if it's on the desktop, I can just plug it into the USB for power and for testing and uploading programs. And I've also made it so that I can easily unplug it from the garage with this. So it's plugged into power and the lights, and just unplug it and bring it upstairs. And then in terms of peripherals, it's got some diagnostic lights to tell you what it's thinking, like is the door open, is it night or day? And then I've done there's a video on the playlist about this real-time clock, so it has a real-time clock, knows what the time is. There's a video on the playlist about these HC12 radios, so they're basically UARTs. And then it has a door sensor and an ambient light sensor. There are videos on the playlist for both of those sensors, and I'll show you quickly what they look like. This is the proximity detector from DF Robot. It's from their Gravity series. It's got their wiring's always the same. So black for ground, that little brown one in the middle for positive voltage, and the blue one's the signal. if you just plug this thing into, if you plug it into power and ground, it's got a little light on the back and a screw on the back. And this one is safe for, you can see the 3.3 to 5 volts. So this one runs at 3.3. And if you see the range here at the bottom, it's 0 to 300 centimeters. So by adjusting that screw, you can make it, infrared. You can make it super sensitive, so it can detect. You can tell it that anything within that range must be triggered as having seen it. So you can easily adjust it to the position of your garage door. And in my case, it's above the door with the 3D printed bracket, and that goes onto there like that. And then the second sensor is also from DF Robot, but it's from their Fermion series of sensors, and it's a simple analog ambient light detector, and it comes with the same cabling. They're always using the same cabling with the same color scheme. So, black for ground, red for voltage, and the blue for signal. And then I've got a blue wire on my board on either side, so I know which orientation to plug them in. And that's the sum of it. So let me switch quickly to show you what the program looks like. I'm not going to go into great detail since the playlist is for that. This is the program in the house box. It's, well, just about 200 lines, but a good deal of that is updating the e-paper display with the message that it gets back from the garage box. So it gets a message, which is a comma delimited string, splits it on the comma, and then updates what you saw on the screen based on what it knows. Things like what the garage device thinks that the date is, what it thinks that the time is, in case you need to update that, what it thinks the current minute of the day is, and if the light's on, it's how many more minutes is it on for. That's pretty much it. And then the rest is the main loop, rest of the program. Got a bit of initialization here, initializing the display, initializing the UART, a couple of pins. The two output pins are diagnostic. The input pin is for the button. Oh no, the two output pins are the blue LEDs. Yeah, I forget which box I'm on. The alternating LEDs, and the input is the button, and it's attached to an event, so that when you press the button, it calls the event, and all that event does is sets a flag. So that's this event here, do info flag. And then the program runs in the outer loop and an inner loop. The outer loop is alternating the LEDs. And it only does it for a fixed amount of time before it stops doing it, and then waits for another signal from the garage device. So the garage device can send different messages, and one of the messages is the door is open, and another message is the lights are on, and then a countdown counter to say when to turn that state off again. And then the third message it can get is info, which is to update the e-paper display. Right. That is what the code in the house box looks like. Let's go and have a look at the code in the garage box. This is the code in the garage box, and you can see I've got this defined diagnostics here, and I've undefined it. And when that's on, it's putting a lot more diagnostic output to the serial port, so I can see it in the serial console when I'm debugging it. And I can debug both devices at the same time. If you look at on the playlist at the HT12 radio video, I'll show you how that works in that playlist. And then when I ship it to the the final version, I have optimization on as well. Yeah. So let's see what this looks like. It's mostly in the main program by the look of it, except for check lights. And I did that because it checks the lights for two different conditions. And then some utility functions for time and day. So finding out whether it's daylight savings time or not. Initializing the real-time clock, I set to something called standard time, which is the time without daylight savings time. So it's so if you initialized it during daylight savings time or not during daylight savings time, depending on what time of the year the clock got initialized, it always gets set for standard time. And then it'll just always, if it then is, when it's working, it'll determine if it's daylight savings or not and add an hour. Why does this matter, you ask? Because the device turns the lights off on the driveway at 10 p.m. And that's irrespective of whether it's standard time or daylight savings time. It'll be the time on your wristwatch. When it's 10 p.m., the lights go off. How do they turn on? Well, it uses ambient light. So if it's dark, and two conditions. If it's dark and it's greater than 6, and the time is between 6 p.m. and 10 p.m., then it'll turn on the lights. So they turn on after sunset and they turn off at 10 p.m. And then there's a second condition. I mean, it's nice to have an indicator inside the house to see that you've left the garage door open, but since it can detect the garage door, if you decide to back up down the driveway at 4 a.m. in the dark, so if it's dark and the door is open, the lights automatically go on. If it's dark and the door is not open, then it's after 6 p.m. and between 10 p.m. the lights will go on. And whenever it turns them on for like, in this one it turns them on for open minutes, and in this one it turns them on for dark minutes. So dark minutes is currently set to 3 minutes and open minutes is set to 10 minutes. So if you open the garage door in the middle of the night, the lights will go on for 10 minutes. And I do that because as soon as you turn your car lights on, it's not dark anymore in the garage. So you've got enough time to back out and leave the house. And dark minutes is 3 minutes from the last time it detected it's dark. So the latest they'll turn off is 3 minutes past 10. And those are all constants at the top of the program here, like dark minutes, open minutes, when is it 6 p.m., when is it 10 p.m. And then I'm in New Zealand, so the day of the year when daylight savings starts and the day of the year when daylight savings ends. And that's the long and the short of it. So at the end of this video, I will put a link to the playlist so that you can go and look at the details of how each of these is implemented. Thanks for watching.